All right, here is a short mini lesson on to use the graphs of f prime in the function notation to identify increasing and decreasing intervals and relative max mins of a function. All right, so we're going to be looking at today is how can we use a derivative graph to help us determine things about a function itself. So let's check this out. Graphs of derivatives. Let's have an example here. Given the graph of f prime, identify the intervals on which f is increasing and decreasing. All right, so we're going to be given f prime, so we're going to use example 1 first off. And we're going to identify the intervals in which f is increasing and decreasing. So here's a graph of f prime. Now, when you determine this, in the first part of it, we're going to think back to what do we know about f prime and f? What is the correlation? Now, if you recall, we did our justifications in previous lessons of where we took our graph f and we did analysis of it. And we wrote a justification. And we found that on the interval, f is increasing on the interval, or intervals, so I'll put a little s right there, fill in the blank, because, all right, f prime is positive. So, all right, we also found that f is decreasing on the interval, or intervals, because f prime is negative. Now, we can actually take the converse of this statement and say that f prime is positive, then f is going to be increasing on those intervals. And if f prime is negative, then f is going to be decreasing on those intervals. So essentially, what we need to look for when we're given f prime is where is it positive. Wherever the values of f prime are positive, that means the slopes of f are positive as well. Then that means f is increasing. When f prime is negative, we know that f, all right, all the slopes of f are also going to be negative, and therefore it's going to be decreasing. So in our example number 1, in order to figure out, to answer the question, in order to answer the question, on which intervals is f increasing or decreasing? Well, first off, f is increasing if what? F prime is greater than 0, so it's positive value. So let's look at this graph and determine where it's greater than 0. Well, we have to find the critical points. Critical points, recall, are when f prime equals 0, so critical points or critical numbers are when f prime equals 0 or when f prime doesn't exist. Well, we're given the graph of f prime. Here and here are approximately where our critical points are. So at x equaling 0 and x equaling 1. We can now look at a graph and see that, all right, as we have this graph right here, all these values, it appears from negative infinity to 0 on this interval, all right, f prime is going to be greater than 1. It's positive values. Therefore, f is increasing. That's what we know. Over here, we see the same thing happening, all right? From 1 to infinity, we see that f is also going to be increasing because f prime is greater than 0. It's positive. Where f is decreasing, as we said before, it's where f prime is negative. So on this interval from 0 to 1, we find that f prime is negative, all right, or I can write it as less than 0. We see many textbooks. It's less than 0. Therefore, f is decreasing on this interval. So in here, we have found this interval increasing, this interval increasing, this interval is decreasing because of what we found with f prime. So now you can correlate what we did previously when we did graph analysis. Now when we're given derivative graphs, we're doing the same thing, but we're doing the converse of that statement. Right? The converse statement. Well, example number 2. If you want to try example number 12. Let's, actually, I go back, and I forgot. Let's do part B. Identify where we have local max and mins. All right, well, looking at these max and mins, if we recall, in review, local maximins occur on F. F has a max at fill in the blank. All right. I'm going to say X equaling C or whatever. All right. All right. Because at C, F prime changes from positive to negative. From positive to negative. F has a min at fill in the blank, X equaling C. All right. Because F prime changes from negative to positive. All right. Once again, this C value right here, this C value is our critical point. So is a critical number, a critical point that we have there. Okay. So at each one of these values, we're looking for the critical number. And remember, critical numbers, once again, are when F prime equals 0 or when F prime does not exist. And we want to figure out what sign change occurs when we have F prime. So looking at our graph, we identified initially where our critical points were. All right? We identified right here at 0 and at x equaling 1 is our critical value. So I guess using what we have before, let's use what we know. At x equaling 0, we notice that F prime changes from positive to negative. All right? If that changes from positive to negative, all right, then we know that this critical point right here, x equaling 0, is a max. That's a max. And I'm going to erase some of this other stuff. Apologize. All right, you need a little extra space, or if you want to, in there. All right. Slow. All right. So we have right here, this is a max. Now what we have right here is this critical point. All right. 0. We have x equaling 1. Well, we notice that F prime changes from, we see this is a negative value to a positive value, changes from negative to positive. Because F prime changes to negative positive, this needs to be a min. X equaling 1 is a min because F prime changes from negative to positive. And that's what we found out. That is what happens. All right. If we look at example number 2, we can identify some similar things. All right. Looking at this graph, we see that, all right, where are we going to have increasing and decreasing intervals? Well, once again, increasing, F prime has to be positive. So we can see from increasing, where is F prime positive? It appears, I'm going to get a different color here. It appears from here to here. So increasing, F prime is positive from negative 3 to 0. We can also see it's positive over here. F prime is positive over here as well. All right, what interval is that? That's from 2 to infinity. Where do we see it's negative? It appears to be negative in this interval. F prime is less than 0 from, it appears negative infinity to negative 3. It is negative on this interval. F prime is less than 0 as well on this interval, which is from 0 to 2. So we identify where we have increasing and decreasing intervals. All right, increasing in red, and then we have the decreasing in green. Where do we have max and mins? Well, at our critical points. These 3 points where F prime equals 0 are critical points. When F prime equals 0, these CPs, we know that because this changes from negative to positive, F prime changes from negative to positive, this has to be a minimum. Here at x equaling negative 3. Right here, because it's F prime changes from positive to negative. Because it changes from positive to negative, x has to equal at 0. This is a maximum. And over here at x equaling 2, because it changed from negative to positive, this would have to be a min at x equaling 2. So we can answer all of our questions. All right. Continuing on, let's look at some more one. All right. This is some problems and some examples that you might find in your book. All right. This is similar to number 40. All right. And what it says now is let's apply this to sketch a graph, all right, of f. The graph of f is shown and sketch the graph of the derivative of f. Now the derivative is the slope, okay, of this tangent line. So given this, we notice that we have a straight line, all right? And the derivative, f prime, how does it relate to f? F prime is the slope of the curve. So slope, where are the slopes? Are the slopes of the graph of f. So, since this is a straight line, all right, all we have to do is figure out what this slope would be. All right, so if we take this, we can say, all right, we have a rise of 1, and we could say maybe this is a run of maybe 1/2, a run of 1/2. So if we want to find the slope of this graph, and since it's a constant slope, constantly increasing, it's a line, our derivative will also be a constant. And rise of a run, so rise of 1 over a run of 1/2, we get 2. So 2 is actually f prime. So we're going to graph 2. We're going to graph 2 in green. So we go up here, and it's a constant line. And that is our derivative graph. F prime equals 2. That's our sketch. So when we're doing this, we're always correlating what is f, how does that relate with f prime, the derivative? What is f prime? How does that relate with f? Take this one. The graph of f is shown. Sketch the graph of the derivative of f. Okay, once again, what do we have here? All right, I'm going to do this derivative. Now, once again, we have slopes. Now, if we think about, all right, the slopes, what do we know about the different critical points and slopes of these different things? Well, first off, whenever f prime is positive, all right, f is increasing. Whenever f prime is negative, f is decreasing, right? Also, all right, whenever f prime equals 0, usually that's a horizontal, well, it is a horizontal tangent. But there's a change. It changes, right? F prime changes signs, either from positive to negative, okay, or negative to positive. So, look at this. Right here, we notice that f is decreasing. Since f is decreasing and then stops this, then changes to increasing here, so increasing to decreasing, it appears that this point would be a critical point. That's at f prime equals 0. Well, since f prime equals 0, I'm going to plot that. This is where f prime will equal 0, wherever that maximum is, right there. And since this is increasing here, that means f prime should be positive. So I'm going to make this positive graph right here. Then it's going to go to negative to the next value. Well, right here we see that it changes signs again, so this must be where we have another 0 in a graph. So it must go like this. And then we see that it's going to be negative. Then it, once again, is going to be decreasing, and it's going to be negative again. Oops. Hang on. Wait. Oops. I screwed this up. I apologize. Hopefully you caught that error. All right, we got our 2 zeros. 0 here, 0 here. We also have another change right here, another 0. But I was mistaken. This is not increasing. This is decreasing, so it's going to be negative. All right, negative 2. This is increasing. Why would I have this screwed up? I apologize. This is decreasing. This is increasing. Change up your notes. I apologize. All right, so it's going to be negative. Then it's going to be positive. Then it goes to decreasing again, so the derivative will be negative. Then it goes to positive because it's increasing, and then it goes positive. All right, so I'm going to get rid of this line right here, but that's what we have. All right, decreasing, f prime is negative. Increasing, f prime is positive. Decreasing, f prime is negative. Increasing, f prime is positive. And so we sketch the graph right here, once again, of our derivative function. All right. Well, let's continue. I'm going to check out the time. We got time for one more application. All right, and we're going to give them some information. So let's check out, let's see what happens here. All right, we're going to supply the appropriate response to this. Okay, this is examples like you would see on page 336, 49 to 53 odd, and different ones like that. So assume that f is differentiable for all x, and the signs of f prime are follows. So f prime is, all right, greater than 0 from negative infinity to 2. Now, what I always do before I go in this, usually whenever you have problems like this, they always tell you what is happening to f, what is happening to f, what is happening to f. Okay, well, if we know about f prime going to be greater than 0, that means that f is, hopefully you recall, yes, it is increasing on that interval. When f prime is less than 0, then f is going to be decreasing on that interval. And when f prime is, once again, greater than 0, f is going to be increasing on that interval. So this is going to be an increasing interval, increasing, so increasing, once again, decreasing interval, and increasing for f. All right, so we're going to figure out what is happening here. Well, in this problem, we are given a function. It says g of x equals f of x plus 5. And we want to figure out the appropriate inequality, all right, so fill in the blank. All right, it's going to be positive or negative. Well, to figure this out, to say g prime of 0. Well, in order to figure out g prime, we probably want to find out what g prime of x is first. And since g prime of x is dictated by f of x plus 5, we're going to know that g prime should equal f prime of x. And then the derivative of 5 is 0, so it's just going to be g prime of x equals f prime of x. Now from here, we're going to identify, all right, g prime is 0. So we're going to plug 0 into here. Well, g prime is equal to f prime of 0. Well, f prime is 0. If you look at our little values, we're plugging 0 into the derivative function. All right, so we look at our intervals. Where do we have 0? 0, x equaling 0 for the derivative would be on this interval. All right, so we would know that it would be negative, f prime would be negative. All right, so it would be less than 0. We also know that f, or g, would be increasing on the interval. We have some other ones. Just a couple more. If we have this, okay, if we know that g of x equals negative f of x, that means if we're to find g prime of negative x, we first need to find g prime of x. In this case, it's going to be negative f prime of x. The negative is a constant, so we write that out. All right, so we look at this. We're actually finding the opposite of f prime of negative 6. So we look at that. We look up here and say, okay, where is negative 6? Negative 6 would be on this interval, x equals negative 6 for f, because all I know is about stuff about f, right here. And what we got right there is going to be greater than 0. However, we do have that negative there. We do have that negative. So because we have that negative, the positive will then turn into the opposite, so f prime would also be less than 0. There we go. All right. Well, hopefully you get it. Do we have another one? Let's go on. Okay. Last one. Certainly not least. For this one, once again, we have g of x equals f times, or f of x minus 10. So that means f of x is being shifted to the right 10 units. All right, and let's find the derivative of this g of x. Derivative of g of x, we have to use the chain rule because we have a composite function. Will be f of x minus 10 times prime times derivative of the inside, which would equal 1. So this would actually essentially equal f prime of x minus 10. Well, we're plugging in 0 there, so we're looking at f prime of negative 10 when we plug in 0. Well, f prime of negative 10, once again, when we plug in x equaling negative 10, is going to be in here. So g prime of 0 would equal f prime of negative 10, which would be greater than 0, all right, according to our little chart. All right. Well, those are the values on the derivative. And for those that are watching this video, here is our daily quiz that we can do tomorrow. So your assignment is to basically do this daily quiz. All right, have this done for tomorrow. All right, it's one question. Find the open intervals on which the function is increasing and decreasing. You can use your notes. You want to justify your answers for all the values. All right, so finish that up and have that ready for tomorrow, because I'm going to be collecting that. So if you got this, all right, you know what the assignment is, and you should have it done by the beginning of class. All right? And that is our other assignment, but that is going to be due the next day. All right, enjoy, and hope that helped for identifying when the function f and f prime and how that relates to the two graphs.